For number 4, remember to see if it's a vertical tangent. That means the left-hand and right-hand derivatives are both negative infinity or both positive infinity. For it to be a cusp, one has to be positive infinity, one has to be negative infinity. So we have to find the left-hand and right-hand derivative. So left-hand derivative at 0, 0 is equal to the limit as h approaches 0 from the left of f of 0 plus h minus f of 0 all over h. So if we do this, we have the limit as h approaches 0 from the left. F of 0 plus h is the same as f of h, so we get h to the 3/5 power, minus f of 0 is just going to be 0. So now we get h to the 3/5 over h. Remember in class today we talked about how to simplify that. We take the bigger one is in the bottom, the bigger exponent, so h ends up in the bottom, and we subtract the exponents. 1 minus 3/5 is 2/5. So, as h approaches 0 from the left, what happens in this denominator? Well, if we have a small number really close to 0 that's negative, and then we square it, it's going to be positive. Then when we take the 5th root, it's still going to be positive. And as 0 gets closer, or as this value gets closer and closer to 0, this value is going to get smaller and smaller, and it's going to be approaching 0 from the positive side, from the right, because we're squaring that and making it positive, taking the 5th root, still positive. So this means that our left-hand derivative is infinity. Now we need to look at our right-hand derivative at 0, 0. So we've done all the work here. We can just jump to the end here. Limit as h approaches 0 from the right of 1 over h to the 2/5. So as we approach 0 from the right, we have a positive number that's very small, close to 0. We square it, still positive. Take the 5th root, still positive. And as this number gets closer and closer to 0, this denominator gets smaller and smaller, approaching 0 from the right side. So this is also infinity. Since both the left-hand and right-hand derivatives are the same, we have a vertical tangent at 0, 0.